afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. So, coming to the third method to find the solution for the recurrence relation is characteristic roots. Characteristic roots. So, before going to start the characteristic roots, we'll discuss about suppose if the roots are real or roots are same or it is maybe distinct, then what is the formula if the roots are same? Sorry. If the roots are same, what is the formula you have to follow? If the roots are distinct, then what is the formula? So first we'll discuss about the introduction for characteristic roots. Depends upon the roots, what is the equation we can understand with the help of the examples. So what is the definition of recurrence relation? Let an plus c1 an minus 1 plus c2 an minus 2 and so on ck an minus k is equal to 0 where n greater than or equal to k, ck not equal to 0. So what is ck? Ck means the characteristic root that is not equal to 0. Is the linear homogeneous recurrence relation. Linear is nothing but the value is equal to 0, then it is called as a linear homogeneous recurrence relation. If it is in the form of equal to 0, we have to return the equation as t power k c1 into t power k minus 1 plus c2 into t power k minus 2 and so on ck equal to 0. So this equation is called as characteristic roots of degree 2. That means it is expanded up to k minus 2. Then we can call it as a degree of 2. Then it consisting of k roots. That means there are degree of 2 is 2. Then it consisting of 2 roots. Degree of k is 3. It consisting of 3 roots in the equation. So this alpha 1, alpha 2, alpha is the roots of equation 2. These are called as a characteristic roots. Now there are two types of characteristic roots. The first type is if the characteristic equation is a linear homogeneous recurrence relation of degree k, then the recurrence relation has written as an equal to c1 alpha 1 to the power of n, c2 alpha 2 to the power of n and so on ck alpha k to the power of n. So what is C1, C2, C3 are the characteristic roots. Alpha 1, alpha 2 is the corresponding value for the characteristic roots. Suppose the characteristic roots of the linear homogeneous recurrence relation has repeated roots. That means that is 3, 3, 3, 3 like that. It is a repeated roots. Then we have to write the recurrence relation as n equal to d1 plus d2n plus d3n square and so on. So dk n to the power of k minus k into alpha to the power of n. So this is the solution if the roots or characteristic equation consisting of the repeated roots. If it is a repeated roots, we have to apply this formula where d1, d2, d3 are the constant. We take any constant, no problem. But if the roots are repeated, we have to apply the formula is d1 plus d2n plus d3n square and so on dk into the power of k minus 1 into alpha to the power of n. So consider the first example. So solve the recurrence relation an minus 7an minus 1 plus 12an minus 2 equal to 0 for n greater than or equal to 2 where a naught equal to 2, a1 equal to 5. So here the first we need to find the equation and after that we need to find the solution for the recurrence relation. In that solution we have to substitute the initial condition to find the values of c1, c2. Whatever the equation that has given, consider as a, so first term as t square minus 7t plus 12. We have to take it as 12. Then to get to 12 we need to multiply 4 into 3. So that means 4t minus 3t. T take t as common, t into t minus 4 minus 3 as take it as out, t minus 4. The roots are 3 and 4. What is the equation? Roots are distinct. Roots are distinct, we can return c1 into 3 power n, c2 into 4 power n. This is the equation number 1. In this equation, we have to substitute the initial values to get the solution for the recurrence relation. Put n equal to 0 in equation number 1. Then c1 plus c2. That is equal to what is a naught. A naught means 2. Equation number 2. Next, after that a1 equal to 5. n equal to 1. In the place of n, we have to substitute 1. 3c1 plus 4c2 is equal to 5. Now we need to solve the equation 1 and 2 values. Solve the equation 1 and 2 values. Multiply equation 1 with 3. We'll get 3c1 plus 3c2 equal to 6. So after division, after that again we need to subtract 3c1 get cancelled, minus c2 equal to 1. c2 value is minus 1. If c2 is minus 1, then what about c1 value? c1 plus c2 equal to 2. c1 plus c2 equal to 2. Then c1 value is c1 minus 1 is equal to 2, means c1 value is 2 plus 1, that is 3. Then what is the required solution for the characteristic roots? An equal to c1 into 3 power n. What is c1? 3 into 3 power n minus, so c2 into, so that is 4 power n. c2 is minus 1 into 4 power n will get 4 power n is the solution for the recurrence relation. That is the solution. Now consider the second example. For solve the recurrence relation an minus 5a n minus 1 plus 6a n minus 2 equal to 0 for n greater than or equal to 2, where a naught equal to 2, a1 equal to 5. So first of all, whatever the equation that has given, converting into characteristic roots, that is t square minus 5t plus 6 equal to 0. So that means to get 6, we need to multiply 3 and 2. T square minus 3t minus 5 2t plus 6 equal to 0. T, I take it as common. T minus 3 minus 2 t minus 3. Then we'll get t minus 3 t minus 2 equal to 0. From this, what are the values of t? T value is 3, 2. So here, if the recurrence relation has the second order, we'll get 2 roots. So if it is a c power k is 2, then k has 2 roots. That means k has 2 roots. What is the solution for the recurrence relation? That is c1 into 3 power n plus c2 into 2 power n. So already initial conditions are given, that is n equal to 0. N equal to 0, we have to substitute c1 plus c2 equal to 2. That is equation number 1. Then n equal to 1, then 3c1 plus 2c2 equal to 5. We need to find the solution of recurrence. This is equation number 1. Equation 2. We need to solve the equation 2 and 3. That means c1 plus c2 equal to 2. Then 3c1 plus 2c2 equal to 5. To get the cancellation, first we have to multiply the equation 1 with 3. 3c1, 3c2, then 6. So after that we need to subtract. So 3c1, c1 get cancelled. That is c2 equal to 1. c2 equal to 1. Then c1 plus, according to the equation number 2, c1 plus c2 equal to 2. Then c1 plus 1 equal to 2. Then c1 is equal to 1. So we have to substitute c2 value and c1 value. Then in the equation number 1, the solution for the characteristic roots is 3 power n plus 5 power n, 2 power n is the solution for the recurrence relation using characteristic roots. Next, Find the solution for the recurrence relation an minus 6a n minus 1 plus 9a n minus 2 equal to 0. First, whatever the equation that has given, consider as a converting the equation into characteristic roots t square minus 6t plus 9 is equal to 0. So 3 3s are 9 t square minus 3t minus 3t plus 9 equal to 0. Next, take t as common, t minus 3 minus 3 into t minus 3 equal to 0. That is t minus 3, t minus 3. Then what are the roots? T equal to 3 comma 3. Here the roots are same. If it is the roots are same, what is the solution? An equal to d1 plus d2n plus d3n square and so on x to the power of n. Here the two roots are there. Solution for the recurrence relation an equal to d1 plus d2n. That means d2n is nothing but a second term. d2n plus 2 roots x to the power of n means 3 to the power of n is the solution for the recurrence relation. Because roots are same. So both roots are same, you have to apply the formula. So d2n into x to the power of n means 3 power n is the x value. Next, find out the solution for the recurrence relation an, that is t cube minus 3t square plus 3t minus 1 equal to 0. Then we'll get t minus 1 whole cube. That means all the roots are same. 3 roots are same. What is the formula? An equal to d1 plus d2n plus d3n square into x to the power of n means 1 to the power of n is the solution for the recurrence relation. Is the solution for the recurrence relation. Next, consider this example an minus 7a n minus 1 plus 27 n minus 2 plus minus 27 n minus 3. How to find the characteristic roots if there are third order recurrence relation in the characteristic roots? Whatever the equation that has given, that is considered as a f of t cube minus 9t square plus 27t minus 27 equal to 0. First you have to substitute, so that is a t value equal to, so we have to equate it to 0. For which values this value should be satisfied, that will be considered as a first root. So suppose if it is a t equal to 0, then we'll get 0 cube minus 90. So we have to start with the t equal to 1. 1 cube minus 9 plus 27 minus 27. So we'll get minus 8, that is not equal to 0. So we have to start f of 3. So we'll get 3 cube minus 9 into 3 square plus 27 into 3, that is 81 minus 27. So 3 cube, that is 23, 3 3 is 9, 27 minus 9 into 9, 81 plus 81 minus 27. This 27, 81, 81, you get 108. For which value then it is equal to 0? T minus 3 is one of the factor. So based on this, we have to find the next roots in the equation. How to find the next terms? So please consider this one. The one term in the sequence, that is 3. So based on the 3, we have to write what are the coefficient of 1. Coefficient of 1 is, so coefficient of 1 is, so coefficient of 1 is 3, 1. So 2 cube coefficient is 1. What is the coefficient of t square? Minus 9. Coefficient of t is 27. Third one is 27. So first of all put 0. 3, 1 minus 0. Again 3 1 ja 3. So 9 minus 9 plus 3 minus 6. Minus 3 6 ja 18 minus 27. Next 3 9 ja 27. So this is the equation. From this we have to write it as a t minus 3 is one factor, t square minus 60 plus 9. So what is the equation for t square minus 60 plus 9? T minus 3 whole square. That is t minus 3, t minus 3, t minus 3. That is t minus 3 whole cube is equal to 0. Then, so all the roots are 3, 3, 3 only. The roots are repeated. What is the solution of recurrence relation? An equal to d1 plus d2n plus d3n square into 3 power n is the solution for the recurrence relation. Now consider one more example for the characteristic roots. Solve the recurrence relation an minus 7an minus 1 plus 16n minus 2 minus 12an minus 3 equal to 0 for n greater than or equal to 3. And also there are some initial conditions also given. A naught equal to 1, a1 equal to 4, a2 equal to 8. So what is the equation? T cube minus 7t square plus 16t minus 12 equal to 0. We need to find the first root by substituting in the place of t equal to 1. F of 1 equal to will get minus 2, that is not equal to 0. I have to start with 1. Plus 1 minus 1. Minus 1 is 36. So you have to substitute f of 2 equal to 0. So t equal to 0 means 2 cube minus 7t square means 2 square plus 16 into 2 minus 12. That is 8 minus 4, 2 to the 4, 7 ja 20, 4 7 ja 28 plus 32 minus 12. So minus 12 minus 12 minus 20 minus 20, that is 8 minus 28 minus 32, that is 40. Here it is 40, here also 40. That is equal to 0. One of the factor is 2. That is t minus 2. Then we have to substitute t minus 1. So 2. What are the coefficient of an? That is 1. Coefficient of n minus 1 is minus 7. Coefficient of n minus 2 is 16. Last term is minus 2. Then we have to put 0. 2 1 ja 2. Minus 7 plus 2 will get minus 5. Minus 2 minus 5, that is 10. 6. 2 6 are 12. What is the equation? That is t square minus 5t plus 6 equal to 0. So one factor is t minus 2. Another factor is we need to find out t square minus 3t minus 2t plus 6 equal to 0. We'll get t minus 3, then t minus 2. Okay, so that is t minus 2 whole square and t minus 3. So two roots are different. One root is, so two roots are same, one root is different. How to find the recurrence relation? That is t equal to 2, 2, 2, 3. Then how to write c1 2 power n, c2 n into 2 power n, because what is the equation? d1 plus d2n into x to the power of n. That is second term is n into x to the power of n. Third term is c3 into 3 power n. So we need to substitute n equal to 0 in the equation number 1. A naught equal to c1 2 power 0, c2 2 power 0, c3 3 power 0. That is a naught value c1 plus c2. N equal to 1 in the equation number 1. We'll get so c1 2c, c1 into 2 1, then c3 into 3 will get 2c1, 2c2, 3c3. Then put n equal to 2 in equation number 1. We'll get 4c1, 8c2, then 9c3. We need to solve the equations 2, 3, 4. We'll get c1 equal to 5, c2 is 3, c3 is 4. Then all the roots are distinct. Then we can write first one is c1 into 2 power n. That is c1 is 5 into 2 power n. C3 is n into 2 power n. C2 into n into 2 power n means C2 value is 3, n into 2 power n. C3 is minus 4 into 3 power n is the solution for the recurrence relation. So what we have discussed in the characteristic roots, what is the formula for the equation for the characteristic roots, what are the two types of roots, if the roots are distinct, then what is the solution for the recurrence relation, if the roots are same, what is the solution for the recurrence relation. We can understand all those things with the help of the examples. Thank you.